What's up, people? Okay, so we're back for round 2. Very late to start, but here. Really didn't want to do this second hour. Just because I'm so tired. Woke up at 3:30. Well, I woke up at not to be at work for 3:30. I woke up way early today, and I don't take naps anymore because they just don't work for me. Just can't fall asleep anymore unless it's like nighttime, bedtime. You know what I'm saying? It's just a waste of time to lay there. Alright, so pick up where we left off, and let's try to get some of this done. So we need to determine which option is better here, and it always comes down to that, right? Multiple options, various ways to solve the same problem, and we're going to pick the best option. So option 1 uses R+ to read the dictionary, modify the dictionary, and write back to the file. And then option 2 uses W+ to write back to the file from a local Python save dictionary that is updated every time the associated data point is modified. And it might be faster since it is loading from the JSON file. It skips this step entirely. And yeah, so there's that. And honestly, I would like to think that option 2, using W+ and using a local term, I guess local is the term. It's not in a file, it's in the script that we're working on. Working from, rather. So it doesn't really need to be loaded in. Obviously, I think that's a no-brainer, right? That operating from a Python dictionary is going to be faster than loading in a JSON dictionary and converting it to a Python dictionary, and then doing the same exact thing that you would have done to the Python dictionary. So then it's like, whoa, why do we use the JSON? Well, we obviously use the JSON dictionary because we have to save it in case the script crashes. So basically, like, we would have a save dictionary that is, I guess we can make it like a client attribute, and yeah, that would just consist of all of the data that gets saved, and every time we want to add, remove, well, we're not going to be removing, I don't know, maybe we'll, but probably not. Anytime we want to add or modify any saved data, what we will do is we'll add it to the dictionary, the Python dictionary, that is, it's called like the save dict. And yeah, so I think that should, I don't even think I have to test this, right? I mean, this is a no-brainer, dude. This is a no-brainer. I'll ask ChatGPT instead of actually going and like running a test. I just feel like I don't need to run a test. First option, R+ is trying to read and write to the same file without resetting the file pointer, and there's an issue in JSON no call. Wait, and there's an issue in the JSON no call. It should be writing save data and not save file. Oh, it found a bug in my code. Well, no, it didn't. Anyway, a correct version should be writing save data. Save file, not save file itself. Save data. What is it saying? Open save SA file. Save data equals JSON load save file. So in the dump, I'm doing JSON dump. Oh, okay, yeah, no, that actually is right. Yeah, that's actually correct. Yeah, it should just be JSON dump. And we're dumping the save data to the save file. Good catch, ChatGPT. Good catch. Hey, catch, dude. Um, so basically, this would be option 2 as well. This, well, let's go ahead and flesh this out a little. This is double. Why is this? Why does it seem so far? 1, 2, 3, 4. Okay, because it. Anyway, I'm an idiot. So we're gonna change this. This would be W plus, and access the save file to load the JSON. Actually, this is just accesses the file to dump dump the save dict dictionary. Yeah, and either way, whichever option we choose, the same thing is going to be happening, wherein the dictionary is going to be updated, and then the entire dictionary is going to be redumped to the file. Like, both of them do that. So there isn't really like a functional difference there. As far as like the operations on the dictionary, etc., is one better than one option better than the other. I think they're equal. They both modify the dictionary, and they dump the whole dictionary. Like, that's just the way it has to be. With JSON, that's how it works. You can't just like update a part of the JSON dictionary. At least I don't think you can. Like, that's wrong here. Let's ask about that. Hold on. Can you update only a single key value pair of a JSON save file without loading / dumping the entire JSON dict? Okay, and yeah, let me read what it said about the options here. So it says the first option. Actually, let's fix this real quick. I know this is how I operate, dog. I'm here, I'm there, I'm here, I'm there. That's how it is, bro. Okay, get used to that. JSON dump, and we're dumping the save data. Save. Now, bam. Like that. There we go. It's better. So this is gonna be boom. There you go. Well, in this case, we would actually do the well, we would have to reference the client. Like, how would we do this exactly? So it's okay, client equals client. So then we're gonna do clients dot, we'll call it save dict. Actually, we don't even need, yeah, we don't even need a different line here. We would just replace save data with client save dict, because the, and I'll just put this here. Update client save dictionary with new values. And yeah, it's that simple. And then we would open the file and dump the save dictionary to that file. Bam. So this would not load the JSON dictionary. This would simply dump the client save dict to the to the save file. Easy money. Okay. So that's our two options here. And let's read what we have going here. It requires reading before writing. Seek 0 is necessary to overwrite properly. Okay, and then truncate is needed to avoid leftover data from the original file. Gotcha. And then option 2 is potentially faster. If you're maintaining a local save dict in Python, it's often better to update that and write the entire dictionary to the file when needed. Yes. Advantages of W+. Faster, avoids reading from the file every time. More controlled, you're working with an in-memory Python dictionary. And it's cleaner, no need for seek or truncate. Ooh, I didn't even really think about that. If you're frequently modifying values, keeping save dict in memory and only writing periodically is ideal. If you're frequently modifying values, keeping save dictionary in memory and only writing periodically is ideal. Frequently modifying values, keeping save dict in memory. Yeah, multiple processes may modify the file. If multiple processes may modify the file, you'll need to, if you're frequently modifying values, keeping save dict in memory and only writing periodically is ideal. However, if multiple processes may modify the file, and they're not, so we wouldn't have that problem. You need to handle concurrency with file locks. I've never used file locks before, but I don't think we're going to need that. Just putting that out there. Okay, so yeah, we're going to go with option 2, which is W+. Cool. And then we have Python, can you update only a single key value pair of JSON in a save file without loading, dumping the entire JSON dictionary? Yes, you can update a single key value pair in a JSON file without loading, dumping the entire dictionary by modifying only the relevant part of the file. However, JSON is not designed for in-place modifications because it's a structured text format, not a binary one. That said, here are some approaches. Using mmap for direct file editing. If the key's value is a fixed length string or number, you can use mmap to edit only that part of the file in place. Mmapped file equals mmap.mmap f.file number. I have no idea what's going on here. Then we have data equals JSON loads mmapped file.read.decode. If key to update in data start equals mmapped file find JSON dumps data key to update and code. Okay, this is a lot. Like, this is not going to be works only if the new value has the same length as the old one or shorter. If the new value is longer, you need to shift data. Yeah, we ain't fucking with that. Nope. Nope. Using file input to modify JSON line by line. If you use files line based, for a line, but then you got to iterate through all the lines. Yeah, nah. Works best if the JSON is stored as one object per line, not. Works best if the JSON is stored as one object per line, not a full dictionary. That couldn't be faster either. Bending changes to a separate file, best for a large file. If the file is small, load, modify, dump. If values are fixed length, mmap advance. If JSON is line-based for large files. Okay. What do you consider a small file in JSON? Let's see what your boy says. What your boy says about this. A small JSON file is typically under 1 megabyte, meaning it can be comfortably loaded, modified, and saved in memory without noticeable performance issues. So when your system's RAM, medium, still manageable in RAM, it can be slow if read and writes are needed. Consider incremental updates, line-based processing. Really? Really? Full reads, writes become noticeably slow. Use string methods. JSON.loadFP with file chunks. Modify only specific sections if possible. Avoid full file modifications. Use databases, SQLite, MongoDB, etc. instead. Ah. If JSON is required, split it into smaller chunks or use indexing. Frequent updates or one-time modifications. Ooh, look at this. Would you say your use case involves frequent updates, or one-time modification? I would say definitely frequent updates. Very frequent updates. Also, how big would a JSON file consisting of, let's just say, man, I don't know, 50 card class instances that have 8. Well, we don't actually save that. How big would JSON file consisting of? Let's just say like 50 small to medium size Python objects. How big would a JSON file consisting of 50 small be? Is that right? Also, how big would a JSON file consisting of 50 small to medium sized Python objects be? Since your JSON file is updated very frequently, storing it as a single file may not be the best approach, especially as it grows. Instead, you might want to consider a database or an alternative structured format optimized for frequent writes. Estimating JSON file size. The size of a JSON file depends on the size of each object, number of keys, value types, nesting. Gotcha. Value types, nesting, string lengths. JSON overhead, curly braces, quotes. Oh, chocobo. Chocobo, baby. JSON overhead, curly braces, quotes, colons, and commas. White space and formatting, pretty printed versus compact. Let's assume each Python object has around 10 keys. Okay, well, we don't... With a mix of small strings, numbers, and lists. I mean... That's like a decent... So this is... You're looking at 30 kilobytes, baby. If pretty printed, indented JSON, it might be 20% larger. Compressed gzip, the size could drop by 50 to 80%. Yes, it's still a small JSON file. However, frequent updates, hundreds, thousands per second, can make file-based storage inefficient. I wouldn't necessarily say it would be hundreds per second. I would say it would maybe be... I don't even think it would be that much. Like, well, when cards are moving and stuff, you could get up to like 100 per second. Well, Well, yeah, I mean, yeah, that would actually be like 100 per second, something like that. Maybe not that much. I guess we just have to really test it and see. But anyway, better alternatives for frequent updates. Yeah, since you're updating often, consider SQLite. Fuck, like, do I really need this though? I did want to learn about databases. That was like my next thing. But do I really need this? Like, is this? It is. Could I not just use a JSON file, baby? Is it? It's not that bad. I don't think. Well, let me explain. Okay, so I'm making an online card game that, if I had to guess, would probably be making between 20 to 100 writes. I don't even think per second, but let's just say, like, let's just say that was the case. Let's just say 2 seconds. Per 2 seconds. You're probably making between 20 to, so in that case, we'll just say 10 to 50, but ChatGPT, well, I don't know. Some of them are not that good at math, actually. But anyway, we'll do between 10 to 50 writes per per second. Duh. We're making an online card game that, if I had to guess, we're probably making between 10 to 50 writes per second to a save file to maintain all of the various data points in case of a crash. Using a JSON file. Given that the file is about, well, let's just say 30 kilobytes. Let's just say 50 kilobytes. 50 kilobytes. Would it be worth it to switch over to a database instead of using JSON? Performance-wise. Okay, so they got no SQL JSON database ready for high-speed updates in memory storage with a millisecond updates. Ooh, baby. I love milliseconds, dog. Hey, you know what turns me on even more than milliseconds? Nanoseconds. Yes, at 10 to 50 writes per second, switching to a database would be a huge performance improvement. Really? Over JSON. Writing to a 50 kilobyte JSON file that frequently will cause... But would I really be doing that much? 10 to 50. Like, if we're moving a card, if a card is being moved, that's at least 20 per second. Because of, like, the card, that's like, you know what I mean? Like, it's, so that is probably 20, you know, let's say 20. So at least 10 for sure. 10 to 50 writes per second switching to database would be a huge performance improvement over JSON. Writing to a 50 kilobyte JSON file that frequently will cause disk I/O bottlenecks. Each write requires reading, modifying, and writing the entire file, but not if I don't. Not if I. But remember, I'm using W plus and not reading the file each time. I'm only writing it. Would it still be better to use a database, even if writes were only to 20 per second? Yeah, yeah. Oh, okay. Issues in multiple parts of the game are need to read, write simultaneously. You'll run into file locks. Yeah, but we're not. We would need that. Let's think about this for a second. Let's think about this for a second. All right. So, if and we had uh, the save thread, and all it did was like check that save dictionary, see if it's changed, and if anything is changed, we would then rewrite the file and just overwrite it with the new dictionary. Um, the only time that the I don't even think multi-threading. I don't think we would have concurrency. So we have the main thread, which is making all the data changes, right? We update that dictionary. Now the dictionary would be shared, that local Python dictionary. So that might be a concurrency issue because it's going to be accessed. And then on the thread, the save thread, baby, because we got two threads going, right? Changes. Same. Link between them is the save. Okay. With Python file. And that would be concurrently accessed. So we would have to use locking there. No big deal. That doesn't require locking IO, which is another benefit of using the option that we chose, unless we end up going with database. So here we go. Discard button next to each write requires reading modified blah blah blah. Concurrency in multiple parts of the game need to read write simultaneously, which we won't have that issue because the yeah, basically that save dict would just be the liaison, the middleman between the two threads, okay? And yeah, whenever we save the data, it would access that dictionary. Whenever we load in the save data after a crash, we would do it through the save thread, and the save thread basically just load in the save dictionary, and it'd still be the liaison. Bam, simple, like super easy, right? Very easy. I've actually, like, I can picture this in my mind perfectly, and I'm like, damn, that's actually pretty good. Blame the voters, baby. Blame the voters, dog. They done it. They done it. Okay, so let's continue. It says, remember I'm using W plus and not reading the file each time. Only writing it would it still be better to use a database even if writes were only 5 per second? Yes, even if you are only writing with W plus, a database is still a better option for 520 writes per second, and here's why. W plus overwrites the entire file each time, even though you're not reading the JSON before writing each W operation. Erases the entire file, still has to serialize the entire dictionary, performs disk I/O for every write, which is expensive over time. Okay. And then databases, on the other hand, modify only the specific data points. They don't rewrite everything. Ooh. Ooh. Risk of data loss on crash. Risk of data loss on crash. Using W plus means that if the game crashes mid-write, your JSON file would become truncated, partially written, completely corrupted with an empty file, missing updates since each write is a full overwrite. Damn, I didn't think about that. I didn't even think about that, bro. Ooh. Yeah, so like technically we would probably want to use A+. See, ChatGPT AI can really help you think out of the box. Because AI, the human, they're not like, they don't get, what do you call it? Like, they don't see into the future, you know what I mean? They're not like creating this fantasy world where your results are correct. They just go off of like the data around them. There goes a fucking disconnect. Come on, man. What are we talking about here? Can I go 5 minutes without getting a DC? Because if it happens for more than like 3 seconds, they just go off of like the data around them, you know? Yeah. That's true. So, risk of data loss on crash using W+. Yeah, we got this. Databases handle transactions, meaning they either fully save or don't update at all. Atomicity. Atomicity. I've never heard that word before, and it's the most awkward word I've ever used in my entire life. Atomicity. Atomicity. Okay, it sounds a lot cooler when you say that. Atomicity. But it's atomic. Atomicity. Atomicity. That can't be a word. They just made that up. JSON isn't optimized for writes. Every time you write, Python has to serialize the entire JSON object, write everything to disk, flush it to ensure data is safe. Databases are designed for frequent updates using efficient indexing and avoiding unnecessary writes. Oh man. Well, boys, you know what this means. I forgot to start my timer. So, yeah. Let's see, how deep are we here? 33, baby. Okay, so we got 26 minutes and some seconds left. That's nothing. Databases are designed for frequent updates using efficient indexing and avoiding unnecessary writes. Performance difference. W plus JSON versus SQLite. JSON W plus. Write speed is slower. Data safety is risky. Concurrency is problematic. And then scalability is harder to scale. SQLite is faster, safe, multiple processes, easily handles thousands of writes per second. So, should you switch? If your game writes 520 per second, still we're switching to SQLite or Tiny as JSON. If your writes were once every few seconds, JSON could still work. Once every few seconds. But at 520 writes per second, a database is the better long-term solution. You are the fucking man, chat. GPT, man. Tell you what, I gotta start using what you call it, the free one. DeepSeek. DeepSeek's been hit on the block and is better. And anyway, China, right? Better in China. Okay, so what are we doing here? Okay, let's read the recommendations here. So it says the best alternatives for your use case. So I guess, guys, one more question I'm gonna ask. So why would we use JSON at all? Like, why would we? What is JSON? It's gotta be. There's gotta be a reason. JSON is configuration and settings files used for storing static or rarely changed data. Okay. Example, config JSON storing graphic settings or key bindings. Okay. Okay, that makes sense. Okay. That's I get it. Okay. Okay. Data exchange, APIs, web apps, etc. JSON is lightweight and human readable, making it great for transmitting data between servers and clients. Wait. Didn't we use a second here? What do we use for data transfer in the game? We use pickle, right? Yeah, we use pickle. But wait, didn't we determine that JSON was faster than pickle? Hold up, dude. I just realized something. I'm like, wait a second. Let me search for this. JSON versus text versus import. JSON versus pickle. Pickle is way 4x faster for simple. In a general speed test for serialization and deserialization, pickle was 4x faster than JSON. Okay, right. We were gonna use pickle because it was faster, but JSON was okay. Because I was wondering, I was like, wait, shouldn't we switch? Should we switch to JSON for data transfer? And then I remembered, no, because JSON is actually slower, and the only reason we would switch to JSON is if it was faster. But pickle is 4x faster than JSON. But the problem with pickle was the issue of changing a specific data point. Oh, but wait, since we can't actually change specific data points anyway using JSON, like without increasing the overhead, and since we rewrite the entire dictionary anyway with JSON, why would we not just use pickle if it's faster? Like, we don't need to read it. Remember, because before I was still confused. I was still working it out, you understand? And it's still happening right now. This is how things work. This is just how it is. This is the process. It's the process. This is how it is. This is what happens. You're like, oh, I'm wrong, and then you're right, and then you're wrong again, and then you're right, and then you're wrong again, and then eventually you're like, okay, now I really understand. And then a year later, you're like, oh, I could have done that better. But ultimately, we could use pickle. We could use pickle. We could not use JSON because pickle's 4x faster. So if pickle is so much faster than JSON, then oh, I love it. For the win. If pickle is 4x faster than JSON, what about using pickle? So JSON is lightweight and human readable, making great for translating data between servers and clients. REST APIs return JSON responses. Small and infrequent writes. If you only need to save once in a while, JSON is fine. It's saving a game's progress every 5 minutes. cross-platform compatibility. JSON works across Python, JavaScript, C++ without conversion issues. The game's save file format that needs to work across platforms, and like, so when JSON fails, frequent updates, large data sets is not returning millions of records. Leaderboard with 10,000 players use the database instead. Concurrency issues, if multiple process players write the same file, you risk file corruption or race conditions. Lack of indexing and querying, JSON doesn't allow fast lookups or filtering like a database. True that. TLDR, JSON versus database, reload speed, read speed is faster for database. Yeah. Slow, risk of corruption, config, API data, save files. So why use JSON for static or rather modified data? Config files, simple game saves. For compatibility, easy share across platforms, and for human readability. But if you're doing frequent writes per second, your database is almost always better. Okay, baby. Okay, baby. I'm with you. So, looks like we're gonna go with the DB after all. Ain't that a mother... Hey, we needed to learn about this stuff, right? Like, I actually needed to learn about the file operations. Does it make me want to cry a little bit? Yes, it does. Because I don't like wasting time. But it wasn't a waste of time. Because now I know. And really implement too much code. It was all mostly thoughts, you know. So, ultimately, we're going to switch to a database. Unless, I forgot about this, unless Pickle is fast enough that we don't need to use database. What about using Pickle instead, since it's 3 to 4x faster than JSON, or since we are writing? Would it still be worth it to use DB instead? Using Pickle instead of JSON would definitely be faster for writing, but it still has major drawbacks compared to a database. Faster serialization, 34 faster writes. Pickle doesn't convert data to a text-based format, so it's much faster than JSON for writing. Yeah. We already know this. It supports complex data types. You can store Python-specific objects. Mix data type. Sort Python-specific objects, tuple sets, custom classes, which JSON cannot. Oh, JSON can't handle tuples or custom classes? Is that actually true? Damn, are you telling me we couldn't have even used JSON? JSON can't handle tuples? Hold up, bro. You gotta be shitting me. Can JSON process Python tuples? When encoding, we're going to be converted to Python in this. Python class instances. Here now. Can directly process Python class instances because it's a text-based data format designed for representing simple data structures. Like, you can serialize Python class instances into JSON format using the following method. Convert the class instance to a dictionary, which stores the object's attributes. So you have to skeletonize the data. Damn, son, where'd you find that? Well, I feel like a straight asshole right now, because I didn't even like. Oh wait, I'm tripping. Well, no, I'm not actually. Well. So like I'm thinking of how we'll keep track of card data, and I'm pretty sure we would have to yeah, we would have to do something like this using the dunderdict to do that. Yeah, we'd have to use the dunderdict attribute to extract basically um, the XY display layer. Because that would need to be preserved to have a perfect save system to restore it back to its previous state, right? That's gonna be a nightmare. Thinking about it. Not that part. The making it work with the server and like the progression of the game. Um, maybe not. I'm tripping. I'm tripping. It's not gonna be a nightmare, dude. I'm over here. I got PTSD from working on this project. Anyway, we're all right. So yeah, we could just use the dunderdict attribute to convert to well, unless we were to use pickle. Pickle would be faster. I mean, we still could skeletonize the data though. So I didn't know though that you could use dunderdict and it would convert every attribute like that. Um, that's pretty cool that dunderdict does that, and you don't have to manually do it. That is something that I want to. I'm gonna put this in things to do. I want to remember this, or we'll put dunderdict to skeletonize class instances. Concerning a way to easily skeletonize class instances and put them in a format which JSON can handle. We can use instance, or was it class? Fucking can't type. Class name dot dunderdict to accomplish this. So dunderdict to skeletonize class instances, concerning a way to easily skeletonize class instances and put them in a format which JSON can handle. We can use class name dict to accomplish this. Was it? It's not an attribute, it's a method, so we'd use. Wrong again, lover boy. It is an attribute. It's not a method. You don't follow it up with parentheses, dog. So that is its final form. You dig? So what do we do now? Well, keep in mind, pickle can handle class instances without skeletonizing. So you don't need to do this with them unless doing this would result in better. It's all about performance, man. You already know the fucking answer to this question. What are we even talking about? God, of course. Christ, man. Okay. Now. Oh, Lord have mercy on me. We done switched it up again, didn't we? So, moving on. Alright, so more space efficient. It supports complex data type. It can store Python-specific objects, tuple sets, custom classes, which JSON cannot. It's more space efficient. Pickle's binary format is smaller than JSON. Okay, that's cool. Pickle still isn't ideal for frequent writes. It still overwrites the entire file. Okay, you're still doing 50 plus full writes per second. I actually corrected you on that. It was more like 10 to 20. We'll say 10. I just say 10, maybe. Okay. It's not human. We don't care about that. Debugging becomes harder. Not cross-language compatible. And loaded easily in JavaScript. I don't know if we necessarily need that. It only works in Python. Corruption risk on crash. If the game crashes mid-write, you can end up with a corrupted file. That is an issue, right? I understand this. Yeah. So, SQL is still fucking faster, man. Better than JSON, but SQLite is still the best choice. If you want a quick speed boost without changing much, Pickle is better than long-term reliability, performance, scalability, SQL. You think you're so damn smart. For 10 to 50 writes per second, I still recommend switching to a database. It prevents file writes and handles concurrency better. Would you like help setting up SQLite for your game, or do you want to try optimizing Pickle first? No, we're just gonna go with the database. Oh, man. Yeah, we're just gonna go with the database because here's the deal. I needed to learn about databases anyway. So I learned about file operations. Cool. That's beneficial. I needed to do that as well. Congratulations, dog. You graduated your file op 101. Now, I could just go with Pickle. It would work. It would probably be fast enough. It would be probably, well, maybe that's not true because of the fact of data corruption. We could, although, probably fix that by appending and then deleting the old version, so we would like always have, you know, we'd have like two copies, like one completed and then one that we're writing. So if it crashed while we were, or got corrupted for whatever reason, or, well, it could still corrupt the entire file. So we would have to have like a backup file. We have to like a backup to the backup. That's not cool. We don't need backups to the backup. We just need one backup. I heard it was supposed to rain. I forgot I had my windows down. So, all right, yeah. So we needed to learn about databases. I'm actually kind of excited because I wanted to learn about databases. Databases are something that I learn about. That was the next thing. I was actually taking a course on, was it PostgreSQL or was it PostgreSQL? Can't remember. But it's PostgreSQL because I remember the icon. Anyway, so I actually learned, like, I watched some of a course and did a little bit of work, course on like Udemy or something. Anyway, long story short, we're just gonna go ahead and do the frickin' database thing. Granted that it's not like too hard. If it's like too hard, we'll just go with the Pickle version. And yeah, so let's go ahead and just figure this out. Okay, I think I will go ahead and use the database. Well, let's go back up here. ChatGPT doesn't need to know my decision. I was gonna ask it about my different options, but it already listed that. Is it? Here we go. All right. So these are the 3 options it gave me for using a database. It gave me SQLite, which says is recommended. I don't know why. Lightweight, file-based, supports transactions, and much faster for frequent writes. Cons: it is slightly more setup than JSON, but easy to use. And why: you can do single row updates instead of rewriting the whole file. Gotcha. Okay, so we would import SQLite 3, SQLite 3 connect, game data DB. Gotcha. So we're like connecting to the database through file, and then we say cursor equals connection.cursor, whatever that means. I guess that's like file location, basically. Same thing. It's like byte location, but instead it's called a cursor location. Example table for game state: cursor.execute, create table if not exists. Game state key text primary key value text. Value text. Def update game state key value. Cursor execute. Insert into game state key value values question mark on conflict key con commit. Okay. Update game state player health and then 100. Okay. I don't know what on conflict means, but I guess. Oh wait, here we go. On conflict key, do update set value equals excluded dot value. I don't know what that means. We can figure that out. Okay, then we have TinyDB. It's a NoSQL. So this is SQL, and this is a NoSQL. So we have the NoSQL JSON-based DB. It still stores data in JSON, but allows single record updates. Where are we at on time here? 58 minutes. Damn, I knew. My internal clock knows when I'm getting close to the hour mark, okay? It knows. I was 1 minute and 36 seconds off, dude. TinyDB is a NoSQL JSON-based database. It's a JSON-based DB. Still stores data in JSON, but allows single record updates without rewriting the whole file. It's still slower than SQLite, but still much better than raw JSON. Okay. Well, that's cool. I didn't know about that. TinyDB. There we go. From TinyDB, import TinyDB query. DB equals TinyDB game data JSON. Game state equals query. And then we say DB upsert. That sounds dirty, dude. Upsert. Jesus Christ. Key, and then we pass in a dictionary with its key, player health, value 100, game state, dot key is equal to player health. Okay. And then, I mean, that's pretty simple. And then Redis, like redistribution for real-time performance. It's super fast in-memory storage, perfect for 50 writes per second. It needs a Redis server running, not persistent unless you enable it. Best for if you need real-time updates plus periodic saves. Super fast. Like when it says super fast, okay. Use SQLite if you want persistence, efficient writes, and minimal setup. What do we mean persistence here? But it's okay. So Redis is not like we need it to be file based, right? Redis, um, Redis wouldn't work for our application since we need the data saved to a save file, right? Redis is only for local in-memory storage. Whoops. So use TinyDB if you like JSON but better write performance. Use Redis if you need extreme speed, but pair with a database for persistence. What does it mean, persistent? Like, it's really much supports transactions. Like, does that mean it's stored? Like it is stored? Is that what it means by persistence? What do you mean by persistence? Alright. Persistence. You're right that Redis is primarily for an in-memory store, but it can persist data to disk depending on the configuration. However, for your use case, frequent writes plus needing a save file, Redis alone isn't the best solution. So Redis persistence option, not just in-memory. Redis can persist data, but it's different from a traditional. You didn't tell me what persistence means. Redis persistent option is not just in memory. So persistence means like storage, like it's still there. Like persistent means you keep going. Like persistence. So like persistence means like you're keep going. The data keeps going. It's still there. I guess it's a weird word to use, isn't it? Or maybe it makes more sense if I understand it better. Redis can persist data, but it's different from a traditional database. There are two main persistence methods. It can persist data, but it's different from a traditional database. There are two main persistence methods. There's the RDB, which is a snapshot-based persistence, saves the entire dataset to a file at fixed intervals. Faster for reads, but data loss can happen between snapshots. Not ideal if you need instant real-time saving. It's like ghetto. I understand that. It's a ghetto save system. I can appreciate that. AOF append only file logs every write operation and replays it on restart. And replays it on restart. More reliable but slower. File size can grow very large over time. Neither RDB or AOF is as efficient as a real database for frequent persistent writes. Oh, persistent writes. Okay, I can say it. So persistence just refers to again and again. So persistence in this case does just mean what the word persistence means. I was just not using my brain correctly. Why Redis alone isn't ideal for you, but default Redis data is lost if the server crashes unless AOF RDB is enabled. Even with AOF, writes are still stored in memory first, which can be risky if you need immediate file-based persistence. Doesn't handle large save files well. Redis is best for keeping hot data in RAM, not for storing persistent game state. Okay. Best alternatives, SQLite, persistent and fast. For frequent writes with permanent storage, SQLite is better than Redis for your use case. Data is always saved to disk immediately. Transactions ensure no data loss. Faster writes modifies only specific data, not the whole file, and less RAM usage compared to Redis, since SQLite doesn't keep all data in memory. Less RAM usage compared to Redis. is in memory and with persistence is still very fast. Some, but risk of loss depending on config. Always saved to disk. And then we have write efficiency is less efficient, logs every command. So when we need it for write efficiency, it's not very efficient. Why? Because it logs every command and it's efficient. Okay, so we're looking at SQLite. I'm tripping. So SQL is fast enough. So it's not as fast as Redis. It's always saved to disk. But then write efficiency is it logs every command. I don't understand. Like, what is efficiency versus speed? You know what I mean? Oh, it's efficient in that it writes only changed data. Gotcha. And then file-based save is possible AOF, but inefficient. So, right. Okay, so SQLite is the answer. You need permanent saves, SQLite is where to fit. Gotcha. All right, baby. So we're going with SQLite. There it is, and we're done for the day. All right. So I'm just gonna go ahead and put this here as the option number 3. Option number 3: use SQLite database instead. Going with this option after review. So let's go ahead and write this up. 129.25. Didn't have enough sticky shit on it to keep it stuck to the wall, apparently. Even though it weighs literally like a quarter of a pound. Gonna have to use some super glue, boss. Alright, so back to devlog. So this is... Let's copy this, go over here. You hear the flute, baby. You hear the flute. Line number tree fitty tree in client refactor. .py. Okay, so we went from 449 to 556, and we asked ChatGPT about solutions to save file system. Ultimately decided on using SQLite instead of JSON or Pickle. There we go. There it is. All right. So we're moving on to databases, which is exciting, very exciting. I'm actually, like, I'm not joking. I'm really excited about this because, first of all, I love learning new things. That's just what I like to do. I like to learn new things, and this is learning something new to me. So I enjoy it. If I'm learning something new, I am happy. I kind of have like ADD or whatever, ADHD maybe, where I do a lot better when I switch things up every now and then, when I do the same thing over and over. Some people love that. Some people just like to do the same exact thing every day. I'm not like that. I like to do different. I like variation. I like, you know what I'm saying? I like to switch it up. It keeps me fresh and multifaceted, you know what I'm saying? I feel like it's beneficial. So we did an hour and 10 minutes, and Yeah, so we're just gonna say an hour. So 2.5 hours total for the day, which is alright. It's alright. It's not bad. Um, so here's what we're gonna do. We're gonna go get. We're at the correct directory. We're at the root of the project directory. Now we're going to get branch. We are on the right branch. We're going to do get add to add everything. We're going to do get commit dash m double quotes. We're going to paste in the devlog. Go ahead and commit that. We had 5 files changed, 43 insertions, and 41 deletions. We didn't really make much changes, but you know, git push Canasta secondary. There we go. We pushed to the remote, and that's just how it is, bruh. We did that shit. What else we need to do? Okay, we need to make a local backup. So we're gonna go to programming. We're gonna projects, Canasta. We're gonna copy the little man. We're gonna bring it up to the backup. We're gonna delete. Now we're gonna paste this in. We're gonna go into Canasta. We're gonna go into devlog. We're gonna go all the way to the end and make sure it reflects today's date, and it does indeed reflect today's date. Now we're going to rename this to be today's date because that was the last time it was backed up locally. And okay, yeah, we can get rid of this. Why is it? Okay. All right, let's empty that recycle bin. And that's it, dudes. So I'm done. I'm tired. I'm ready to go to bed. Honestly, I'm probably gonna. I need a little bit of sugar so I can stay up a little bit more. A bit more. Play some more watch. Play a game. Watch the end of this Matrix. I was watching the third Matrix movie. I saw Neo go blind for the first time. Never saw that before. So yesterday. It's fucked up. That was actually probably the best moment in Matrix, in my opinion, was when he was fighting your boy and he realized that he was Agent Smith, but like outside of the Matrix. So pretty cool. Pretty cool. Uh, I mean, I'm what, like 15 years late to that, but yeah. Have a good day. Maybe we'll see you tomorrow. Hopefully, I will be able to get some coding done. Hopefully, do more tomorrow, like 4 hours maybe, instead of just the 2.5 that we did today. And yeah, so we're going to learn about databases. We're going to implement it. Hopefully, it's not too hard. I don't think it will be. I think it's basically the same process, just like different syntax or whatever. You know what I mean? And yeah, we'll get that set up. We'll learn something new and get it done. So have a good day.